Hi, Graham. Thanks for your emails today. I've got the first question here, number 13. That's really helpful that you could send me some specific examples like that. And so I'll work through this. I'm not sure how long it'll take to do each one. And I know there is a limit to the size and the length of the videos that I can make and still upload. So I may have to do this in separate videos, but we'll see. So we're going to start by finding the derivative, the first derivative of this function. And so using the power rule, the 3 comes in front times the 1/3, so we'll have 1x squared. The 2 multiplies by the 3 halves, and that gives us 3x. And then for the minus 4x, we end up with minus 4 for our derivative, okay? So the way that we're used to finding maximum and minimum, which are another word for the extrema, is we're used to setting the derivative equal to 0. So our derivative is x squared plus 3x minus 4 equals 0. And we need to find values of x that satisfy that equation. So if we have x plus 4, x minus 1 is the factors of that trinomial, then our zeros are x equals minus 4 and x equals 1. So we have possible maximum or minimum points at x equals minus 4 and x equals 1. The complication, usually what we would do is test those points in the second derivative to see if they are a max or a min for this function. The complication or the added step that this problem includes is that they have narrowed it down to a specific interval. And they want the domain to be any value between minus 5 and positive 2 only. So what happens is with a function like this, with any function, this is a cubic, so it might look something like that, you can see that we have a maximum right here, whoops, I missed, and a minimum right here. But when they talk about the absolute extrema, what they're saying is in a certain interval, what's the absolutely highest point and what's the absolutely lowest point. And so that can change if you change your interval. For instance, if I just look at it between, say, here and here, then the highest point is now this point right on the left-hand side of the interval, right on the left boundary. So even though this function has a maximum, it doesn't occur within the interval negative 5, 2, or whatever it is that we're working with. And so it can't be included as the maximum. So the absolute maximum in this case would be the highest point inside this interval that's specified. So that's what we have to check out, okay? So what we're going to do here is we're going to make a little list and we're going to go at x equals 1, at x equals, I'll start with minus 4. That's our lowest x value. At x equals minus 4, at x equals 1, at x equals minus 5, and at x equals 2, we need to know what the value of y is, because then we're going to compare those, and whichever value of y is the highest and whichever one is the lowest, they're the winners for the absolute extrema. So at x equals minus 4, if I go back in the original equation, which is f of x, and I work out what the y value is, I'm going to get 1/3 times negative 4 cubed plus 3 halves times negative 4 squared minus 4 times negative 4 plus 1. I'm going to do that for each of these 4 values here, and I'm going to see what it comes out to for the y value, and then I'm just going to compare, and I'm looking for the lowest y value, I'm looking for the highest y value in that interval just between minus 5 and 2. So I'm going to put you on pause to save time. I'm going to do some calculations, and I'm going to come back and talk to you about which y value we end up with here. Okay, so hopefully if I'm thinking clearly, which I may not be because it's 9 o'clock at night and I've been doing math all day, And I don't have a calculator handy, but I think maybe I've got these right. You should double check these. What we're looking for is the lowest value of y and the highest value of y. So I think our winners are -4 and 2. So in this case, it turns out that one of the values we got from the first derivative happens to also be the maximum value of the function in this interval. And one of the values that we got from the interval itself happens to be the minimum value for this interval. And so that's what they mean when they say to find the absolute extrema and the values of x at which they occur. So you would say, therefore, the minimum occurs at, and you would put, 2, and you might want to write that as 5/3, is it? I think 5/3. And the max occurs at -4 and 17. Okay, again, I need you to check those calculations. But that's a complete solution. That's what they're looking for. And the specified domain is the interval that they gave you, which is the -5, 2. Okay? So I think I'm going to try another video for the other ones because this one's getting on the long side. And so I'll send you this, and then we'll have a look at 25 and 27.